properties of prisms. Now, a prism is a three-dimensional shape that has two congruent bases. Congruent means equal. We name them by the shape of the base. So if the base is a triangle, it's a triangular prism. All sides are rectangles. When we say sides, we mean the lateral faces. So there's two bases, and then we have lateral faces. And the number of lateral faces will equal the number of sides on the base. So if our base is a triangle, each one of these, right, we have the right side, the left side, and the bottom. Each side is a rectangle, and there will be three of them. So if you want to see like how many are there of things, well, there are two bases. There are n lateral faces, where n is the number of sides of the base. Again, so if we have a triangular base, then n is 3. If we would have a rectangular base, then n would be 4, and so on. Total faces, that is lateral faces plus bases. If we take 2 for the bases plus the n lateral faces, that's how we get 2 plus n. Vertices. Vertices are the points. So if we think about this piece here, like this is a vertice. It's where they meet. And if we want to know how many vertices there are, we can take 2 and multiply by the number of sides of the base, right? That's what n is. And that would then tell us the number of vertices. Same with edges. Edges are these pieces, right? They connect faces, they connect bases, that kind of thing. So if we want to know how many total edges are there, we would just take 3 times the number of sides on the base. Okay, so let's do this. Here we have a rectangular prism, and I know that because we have rectangles, right? The fun things about rectangular bases is that everything is a rectangle, right? The base, the face, lateral faces, all of those things. So one thing to think about, in a rectangular prism, we have 2 bases and we have 4 lateral faces. So that means we have 6, n plus 2 equals 6 total faces, because if we have a rectangular base, that means n is 4. So if we want to know how many vertices, I mean, we could count, or we could take 2 times 4 and get 8. Let me show you where those are. Well, first let me get rid of all of this crap. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There are the 8 vertices. And we would have edges. Edges is 3 times n, so 3 times 4 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew, almost missed it. But that's what all of those items are from before. All right, this here is a triangular prism, because again, we can see 2 triangular bases. That means we have, because the side has 3, that means n is 3, so we have 3 lateral faces. And then we could go on the same thing. If n is 3, how many edges, how many vertices? So 2 times 3 is 6 vertices, and 3 times 3 gives me 9 edges. A cube is just a fancy rectangular prism. And I wanted to bring this up because a cube simply means that all 6 sides are the same. But we still have 2 bases and 4 lateral faces. They just all happen to be the same. But it's important just to recognize that a cube, while it is special, is simply just a rectangular prism. And the last thing that I want to really talk about is when we talk about a prism, I want to show you the net of a prism. Now, a net means if we have ourselves a rectangular prism, and you're like, well, what does that really look like? Well, think about if it's laying flat. So think about a tissue box. I love tissue boxes for this. So if we have the bottom of the prism and you're like, well, I can unfold each end, right? Those are the bases. And then we had like smaller sides, and then we had the top, right? So like if this is the bottom, and then this is the top, and we'd say, well, this might have been the right side and this was the left side. So you can see how these we have these two rectangles would be the same, and then these two rectangles would be the same, and then as we know, the bases are the same. So just an idea of a net is when you take a three-dimensional figure and then you like unfold it. So if you take, if you get a package in the mail that comes in a box, you can unfold that rectangular prism and you would have a net, which is just kind of fun to be able to like really visualize what we're talking about.